Right, so for your first topic in finals, as you can see, we have here the sequences and strings. Okay, so I hope most of you have done an advanced reading so that if ever that there is a part that you can understand, so take note on that one and then just ask that question as we go on our topics. All right, so for the sequences, we only have two, okay, which is the recursive and explicit. But before that, I'd like you guys to know what is the meaning of sequences. So the only difference when we see sequences from set is the list of objects is arranged in a definite order. Okay, that's it, and everything is quite the same already. Okay, in sequences, arrangement is important, but in sets, it doesn't matter. Okay, so the same sequences, it could either be finite or infinite sequences of objects, and elements may be distinct or repeated. Okay, so in sets, you can also repeat some elements. You can also have a distinct elements. So quite the same. Okay, so in here we have examples of a sequence. So this is one. This one is a finite and repeated. The second one is the recursive. Okay. So from the word itself, recursive, so I hope that you guys have researched what is the meaning of recursive. Okay. Meaning you can only predict the next element or the next sequence or term if you only know the past terms. Okay. So like this one. So if you know the first two terms or first three terms, then you already have a hint what could be the fourth term or the fifth term. Okay. So from here, as you can see, we have a pattern. So 3, 8, 13, 18, and then 23. So just keeps on adding 5 on every term. Okay. So you will not know the fifth term unless you know the fourth term. Okay. Because let's say you just jump to an answer 25, but the last term is 18, and then all you need to do is add 5. So you already know wrong with that one. So you have to know the past terms or the last term before you can answer the next term. Okay. Which is 23. And then the second one, I mean, the third one is an explicit. So in number three, in explicit, you don't need to know the past or the first one or first, second, and then third term. Okay. So as long as you know the formula or the, what could be that one? The definite rule. Okay. The rules, the range, then so be it. As long as you know those two, then you'll already know what is the value that you're looking for. Like for example, what is the value of or what is the uh 55th term. Okay. So you don't need to know the first 54th term as long as you know the formula. Okay. That's why we call that one explicit, since all you need to do is find out what is the formula and then the range of it. Okay. So like this one, it has a list of squares of all z plus. So in a 10 term, so just square that one. So 10 times 10, then that's already 100. So you didn't need to know the first 9 term. Okay. Okay. So moving on, we have here the full definition of recursive. So as I have mentioned a while ago, so it is a formula that refers to previous terms to define the next term. Okay. So it must have a starting number. Without a starting number, you won't be able to answer the following sequences or following terms. So as you can see right here, we have first 5 sequence or first 5 terms. And then as you can see, this is the first, second, third, fourth, and then fifth term, and so on and so forth. Okay. And we have this formula. Okay. So a sub n is equal to a sub n minus 1. So as you can see, you have to know what is this e sub n, because if you don't know what is this e sub n, then you won't be able to get the next term. Okay. Wherein the range is only ranging from a more than. Okay. Your n should be more than 2. Okay. And above. Okay. That's your range. So as you can see right here, this is now your second term. So all you do is get the first term, which is your a sub n before, or a sub 1. So your a sub 1 is very obvious, which is 3, of course. So just put it here. So a sub 1 is 3 plus 5 is equals to 8. Then the same pattern. Just get the value of a sub 1 and then put it in here, and then you will get the next result, which is 13. 8 plus 5 is 13. And then a sub 3 is equal to, oh, sorry, this one is a sub 2. A sub 2, yeah. And then this one is a sub 3. And then the last one is a sub 4, which is you need the value of a sub 3, and then just add 5, and then you will get 18. Okay. So sorry for that one. I thought this one is a sub 2, and then this one is a sub 3. So up to a sub 4. Okay, so as you can see, you won't be able to answer the a sub 4 unless you already know the value of a sub 3. Okay. So yeah, that's how you compute or to know the value of the next term. So is everything clear so far?
Sir, question, sir.
Yes.
Sir, if I'm correct, Fibonacci sequence is a recursive sequence, sir?
Yes, yes. It could be also, yeah, only a recursive, not explicit. Any other question? Hello?
Hindi po.
Okay, so for recursive, as long as you know the pattern wherein the difference here is 5, okay, so you will already know the next term that you're looking for. Okay, next one here is explicit, wherein you don't need to know the position. I mean, you don't need to know the past terms, okay? But in here, you only need to know the position, okay? So, sorry, I'm sometimes interchanging those two. But anyway, when you say explicit, you only need to know the formula and then the number of terms. Okay, you don't need to know the past or the first terms before you can answer the next term. Okay, so in here we have here the formula, which is n squared. Okay, and the range here is 1 and above. Okay, so as you can see, we have here 1. So 1 squared, just put it in here. That is already your first term, okay, which is 1. And then 2, and then squared it, then you will get 4. And then 3, this is now your result. And so on and so forth. So as you can see, this is your first, second, third, and then fourth. Okay. So all you need to do is put this value onto your formula, and then you will already get the result of that term. So in here we have 16 for the fourth term. Okay, so you could say that this one is a lot more easier rather than having this one, recursive. So as long as you know the formula, then you already know the pattern. So in here, it keeps on squaring the number. But in here, it keeps on adding the number. So both of them, recursive and explicit, has their own patterns, of course. All right? But in explicit, you only need to know the position. So are we clear so far for the explicit?
Yes, sir.
All right, so
Yes.
let's move on to the example. Okay. So if ever that you have a question or if there is a part that is confusing, then feel free to ask me anytime, okay? So don't be shy to ask. All right, so this is the example of recursive. So as you can see, we have here a starting number or the first term, which is 5, okay? So without this, you won't be able to know the next terms, okay? So this is very important when it comes to getting the terms or sequence of a recursive formula or recursive pattern. So here's the formula that is given for this example, and then here's the range that is given for this example. So in here, your n is ranging from 2 to 6, right? So this is your first term. This one now is for the second term. So let n is equal to 2. So all you need to do is put it in here, okay? So 2c sub 2 minus 1 is equal to c sub 1. So what is your c sub 1? It's 5. So 2 times 5, so just change this 1, c sub 1, to its corresponding value, which is 5. So 2 times 5 is 10. And just keep on doing that one. So 2c sub 2 minus 2c sub 3, sorry, 2c sub 3 minus 1 is 2c sub 2. And then just get the value c sub 2, which is 10. So 2 times 10 is 20. And so on and so forth. So just keep on doing that one. So basically, you're just putting this one onto the next pattern or to the next solution. The same with this one into here, this one into here. So as you can see, it keeps on doubling the last value, okay? Because it, as you can see right here, it's 2 times. Okay. So if this one is 3, then it keeps on tripling at the last value. But in here, since this one is just 2, then these ones keep on doubling the last value, which is this one. So 2 times 10 is 20. 20 times 2 is 40. 40 times 2 is 80. And 160. Okay. So sequence here is 10, 20, 40, 80, 160. All right. So are we clear so far for the recursive example?
Yes, sir.
Yes, sir.
All right. So now let's have another example for recursive. Okay. So the same, we have here the first term, which is 3, but just a different formula. Okay. So as you can see right here, it just keep on adding +4 on the last term. Okay. So 3 is the first term. So just add 4. So 3 plus 4 is equal to 7. And then 7 plus 4 is equal to 11. And then 11 plus 4 is equal to 15. And so on and so forth. Okay. So as you can see right here, the sequence here is 7, 11, 15, 19, and 23. Okay. So what's important in the recursive is the starting point and then the range. So in here, depending on the range on where will you start. So in here, it started on the 2 and above. Okay. So are we clear so far for this second example on recursive?
Yes, sir.
Yes, sir.
All right. So once you're done in understanding those examples, of course, you're going to have a seat break. Okay. So in here, write the sequences of the following explicit formula. Okay. So take note, this one now is explicit formula, not recursive formula. So you can do it handwritten, but please write logically. And of course, as usual, take a picture of it clearly. Okay. So in here, here's the given formula, and then the range is starting from 1 and above. So just put the first 5 sequence. So 1, 2, 3, 4, and then 5. Okay. So the same with this one, starting from 1 up to 5. Okay. And then here's the given formula. Okay. So again, just the first 5 terms. Okay. You don't need to put everything. And then the third one here is like a problem solving. So here's the mile age, here's the cost, and then here are the 2 questions. So all you do is analyze those, and then write the recursive formula for this one, and then write explicit formula for this one also. Okay. So there's actually continuation for this one. So number 4, if the sequence formula is given as t sub n is equal to n squared minus 1, and then your n is 1 and above. So write the first 5 times first terms of this sequence, and then find the 55th term of this formula, or using this formula. Okay, so 2 questions for number 4. And then for the last one, if the sequence is defined as using this formula, and then here's the range, so write the elements of the sequence. So in here, a total of 6 elements. 1, 0, 1, 2, 3. Yeah, 6 elements, or 6 sequence. So are we clear so far for your first seat break?
Sir, question, sir.
Yes?
Sir, kailangan pa ba naming ipakita yung solution, sir, or diretsong sequence ta?
You need to show the solution. Okay. Just like this. Okay. So for recursive, then you must show the step-by-step solution on how did you get the first, second, third, fourth, and then fifth. Okay, so the same with explicit. Okay.
Sir, possible ba na, ano, sir? I-word na lang kung kaya.
Yes, of course. Actually, I like it more by word format, but Sam is having a hard time in doing it in Microsoft Word. So you can do it handwritten also. So it's up to you. So you can do it via Microsoft Word or handwritten.
Thank you, sir.
Right. Any other concern regarding with your seat work number one? So five numbers. All right. So I think there's no more question. Next one here is the two types of sequence. Well, this one is actually self-explanatory already. So we have the increasing sequence wherein, of course, it keeps on increasing. So starting from the lowest number up to the highest number. So things right here, this is one is an example of increasing sequence. So 2, 4, 6, 8, and so on and so forth. So it just keep on increasing by 2. And then if we have increasing, we also have decreasing sequence. Okay, so this is the formula for this decreasing sequence. So it keeps on dividing the last term by half. So 2 divided by 1 is 1, 1 divided by 2 is 1 half, divided by 2 is 1/4, 1/8, 1/16, and so on and so forth. So it keeps on decreasing. Okay, so yeah, this is already self-explanatory. So once you're done in understanding all of those, actually, this one is now the combination of uh, explicit and recursive. And then summation, yeah, summation of no, recall this one, geometry. So for now, as of now, you can actually answer 1 to 8 for the letter A, and then 1 to 7 for the letter B, and then A to B for the letter C. Supposedly this one is letter C. Okay, so you can stop doing that since we haven't discussed this one yet. So later on we will discuss this one. So just go back on this one once we have already discussed the summation and then the geometric sum. Okay. So for the letter A, write the first four terms begin with n is equal to 1 of the sequence whose general formula is given as. So as you can see right here, we have here the given formula and then just write the first four terms. Okay. And then we have here the, as you can see, you can already tell that this one is this type of sequence. And in here, as you can see, the first term is already given. So as you can see, this one is already example under of this sequence. So this is like a bonus already. And for the letter B, write the formula for the end term of the sequence. So this one is the opposite of your letter A. So in here, you're going to give the first four terms, but in here, the sequence or the sequences are already given. So all you do is form or make or create the formula out of this one. Okay. And then we have another question for letter B. Okay. So once you're done in writing or in having the formula on each number, so you have to identify if that formula is recursive, explicit, or both. Okay. So both of them has a pattern, of course. Both of them has a formula. Okay. But one of them needs the first term. Okay. The other one doesn't really need the first term. So you can tell that that one is already recursive or explicit. Okay. And for the last one, so for the sequence, we define by this formula and factorial plus 2. And then your range here is 1 and above. So find the third term, or v sub 3, and then v sub 4. And then the summation from 1 to 4 using this formula, v sub I, okay, or v sub n. So later on, we will discuss this one so that you guys can answer this after our discussion. So,
Sir, question.
yes.
Sir, sa letter B ba kailangan pa namin ipakita yung derivation or diretsong formula?
Wala namang derivation. Okay, so you can put directly the answer, I guess. Since creating a derivation is difficult. Okay, so just put the formula for the 1 to 7 and then identify it if it's recursive, explicit, or both.
Thank you, sir.
So you can also do this one using Microsoft Word or handwritten. Okay, so it is now completely on your own preference. Okay, but if you're going to do this one handwritten, please write legibly. Okay. So any other question or concern? None? Are you guys still there? Are you guys still listening?
Yes, sir.
Yes, sir.
Okay. So again, if you guys have a question, so feel free to ask me anytime. Okay. So it's okay if you're going to interrupt me. Right. So here's now the summation and then the product notation, or in other words, it's geometric summation. So first we have here the call this one the variable. Okay. So or symbol rather. So in here it could be a summation or it could be a product notation or geometric summation. Okay. And then both of them has its own index and the lower limit and then the upper limit. Right. So as you can see right here, if it's summation, then the operator or the operation that you're going to use is addition. Okay. And if it's product notation, the only difference here is just the operator. Okay. So in here, you're going to use times or multiplication. Okay. So this is the symbol for summation, letter E or sigma. And then here's the symbol for product notation or geometric summation. So this one is a pi. Okay. So just be familiar on this one. Okay. So if it's pi, then this one is multiplication. If it's sigma or summation, then this one is addition. Okay. So yeah. And then as you can see right here, all of them has an index. Okay, wherein sometimes the index is starting from 0 or 1, or sometimes it could be 20 or 25. And then your n is the upper limit. So this is the maximum range of your number, okay, or your term. So for example, your lower limit is 1 and then your upper limit is 10. So the range here is 1 to 10. And then, of course, it's only increasing by 1, so 1 to 10. Okay. So there's now a total of 10 terms. Okay. So, are we clear so far for this one? Understood? Or you guys still memorizing the... So for now, you don't need to memorize this one. Okay. This is just a way of showing that this one is summation and then this one is a product summation. So are we clear on this one?
Yes, sir.
Yes, sir.
All right. Okay, so here's one example for the product notation and sum notation. So let A be the sequence defined by an explicit formula. So we have this formula 2 times n. Okay, let's say that the n is the term or the position. So that is a sub I is equal to 2 times n. So as you can see, this a sub I is always the formula. Okay, so a sub I is a default symbol or variable wherein this a sub I contains a formula. In this case, the formula of a sub I is 2 times n. Okay, so as you can see, wherein your n is ranging from 1 to 3. Okay, so 1 is lowest and then 3 is the highest. Okay, so take note, the highest number should be always higher than the lower limit. Okay, so do not interchange those two. Okay, so the lower the number, it is now the more that it will be your index or your lower limit. The higher the number, then the more that it is becoming your upper limit. So in here, it's 1 to 3. So for the summation, we have here the a sub I, And then for the first term, so just change this I into 1. So a sub 1. For the second term, 2. For the third term, 3. So a sub 1 plus a sub 2 plus a sub 3. Okay. So basically just whatever is the value of I, it is now also the value of n. So your I in here is 1. So just put it in your n. So 2 times 1 plus 2 times 2 plus 2 times 3. Then of course, since this one is summation, then you have to use plus or addition. So whatever's the result of this one, just keep on adding on the second and then the third term. Okay. So as you can see, we have a total summation of 12 for this sequence or for this formula. All right. And then the same pattern in everything. Okay, so 2 times 1, 2 times 2, 2 times 3. And then all you need to do is change this one from plus into multiplication. Okay, since our notation here is product notation. Okay, so if it's sigma, then your operator is plus. But if it's product, then your operator is multiplication. So just solve this one, then you will get 40. All right. So did you guys get this one?
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Okay. So let's have more explanation or details when it comes to summation. So the symbol sigma takes a sequence of numbers and turns into a sum. Okay, that's what it's called summation. So symbolically, we have here the index. So same. Actually, this is the default formula when it comes to summation. So this is read as the sum from I to 0. Okay. If it's product notation, then the product from I to n. Okay, or from 0 to n. Okay. So here's another one. So consider the identity sequence. So a sub I is equal to your I. Your I here is your n term. Okay. So whatever is the value of your I will be your I, okay, in here. Okay. So A here is just an indicator that this one is a formula. Okay. So before this one is 2n. Okay. But in here it's just simply equals to I. Okay. So if it's a sub 1, then this one is 1. If it's a sub 2, then this one is 2. So you could list this one as 0, 1, 2, 3, 4, and so on and so forth. Okay. So the sum of the first numbers is given by using this formula. So as you can see, we have a starting point of 1, and then we have here a sub I, and then you could say that this a sub I is now equal to I. Okay. So since this one is a very simple formula, okay, actually you cannot say that this one is a formula. It's just an n term, okay, or a position term. So whatever is the value of your I here, it will be your value of your I. So starting from 1 and then incrementing by 1. So 2, 3, 4 up to the its maximum or upper limit. Okay. So the first term, 0, is dropped, of course, since we've started with 1. Okay. So did you guys get this one so far? Oh, this one is actually self-explanatory.
Yes, sir.
Okay, so the one thing that you need to look into is the this one, A and then I. This one is always has an equivalent formula. Okay, so before we have the 2n, AI is equal to 2n, but in here it's just equal to I. Okay, so later on we'll be having more complicated formulas for this A sub I. All right, so we have here the arithmetic summation formula. Okay, so there is actually an explicit formula for the previous example, like this one, getting the summation from 0, 1, 2, 3, 4, 5. Okay, so you can use this formula to obtain the summation of that summation. Okay, well, you can use this one as long as, okay, as long as your lower limit is starting from 1. Okay, but if it's not starting with 1 anymore, like it's starting with 5, 20, 25, or any other number other than 1, then there is another formula for that one. Okay, but if it's starting with 1, then you can use this one. Okay, So here's the intuitive reason. The smallest term is 1. So the biggest term is n. So the average term is n plus 1 divided by 2. Okay, so for you to be able to get the average of this one, so we have this formula, n plus 1 divided by 2. Okay, so here's the formula for the most complete, okay, when it comes to solving an arithmetic summation formula. Okay, so I am now advising you guys to memorize this one. Okay, n minus m plus 1 times n plus m divided by 2. Okay, because whatever is the starting point and then whatever is the upper limit or maximum number, then you can use this one. Okay, as long as it just keep on incrementing by 1. Okay, like for example, this one is starting from 1 to 10, then you can use this formula. Okay, so n here is the upper limit, which is 10, and then m here is the lower limit, which is 1. So 10 minus 1 plus 1 times 10 plus 1. So n again is your upper limit, and then m is your lower limit, divided by 2. Then just solve this one, then you will get 55. Okay, so the same with this one. As you can see, this one is not starting with 1, but you can still use this one. Okay, this formula. So the lower limit is 3, upper limit is 6. So just put here the corresponding value on each of those variable, then you will get 18. All right. So as you can see, this one came from the average formula. Okay, and this one is just actually this is another formula wherein you're getting how many terms in that range. Okay, so n minus m plus 1. So as you can see, if you're going to solve this one, 10 minus 1 plus 1 is still 10, because we have 10 terms for this formula. And then as you can see right here, we have 6 minus 3 plus 1. In here we have 4 terms for this range. Okay, or for this summation. 3, 4, 5, 6, 4 terms. And then in here, the second formula here is just the average. So just multiply those two, okay? The term plus times the average, then you will get the summation from the starting point up to the maximum range. So did you guys understand this one?
Yes, sir.
Yes, sir.
Parang may mga problema kayo. Okay lang ba kayo? Alright,
Okay
so
lang, sir.
okay lang. Nangihina kayo. Kumain na ba
Sir,
kayo?
medyo po.
Medyo ba? Okay. So again, may